Hello everybody, this is Kermit Killed the Cat, and welcome to your fourth Lua 5.2 tutorial. So in this video we'll be going over loops, the different kinds of loops, and how they all work. So what a loop is it's something that allows you to check the outcome of a logic statement, and if the logic statement is true, you execute a certain block of code, just like an if statement. But unlike an if statement, once that block of code is run, that logic statement will be checked again, and if it's still true, the code will be repeated. So this is easiest to show with an example, so let's start by going over the while loop. So we're going to create a variable, we'll call it iter, which stands for iterator, and we'll set it to 0. Then we'll create the while loop, we'll say while, and we're going to be counting to 10, so we're going to say while iter is less than or equal to 10. Then we say do, not then, like an if statement, do. And then we say end on the next line. Then in between these two lines we have the block of code that we want to be executed, so we'll just print iter, and then we'll say iter equals iter plus 1. And most languages have an operator called the increment operator. We could just say iter plus plus, and that would just add 1 to iter, but Lua doesn't have that, so we have to write iter equals iter plus 1 out. So what this statement is doing is, first of all, it's just setting our iter variable to 0, and then we get to the while loop, and this line checks whether iter is less than or equal to 10, which it is, because iter is 0, and since iter is less than or equal to 10, this code is executed, just like an if statement. But unlike an if statement, once this code is done executing, the code control goes back up to this line, and it checks whether iter is equal to less than or equal to 10 again. And since it will still be less than or equal to 10, because iter will be 1, because we increment it here, this code is run again. And this continues to happen until this logic statement becomes false, so the loop will end once iter is greater than 10. So if we run this, I don't know if you can see the console, but the console outputs from 0 up to 10, because our iter variable starts at 0, it's printed, and then 1 gets added to it, and then the loop starts over, and the same code is executed again, up until iter equals 11, and then this logic statement becomes false, and the while loop ends, and then the program ends. So that's the while loop, and the next kind of loop is the for loop. And the for loop kind of gives us a way to automate what we just did here. We won't have to use this outside variable, which is considered unclean in programming, having a separate variable to iterate in most cases. In some cases it's okay, but in this case this would be considered unclean. So the for loop gives us a way to clean this up and automate it a little. So to write your for loop, you just say for, and then you create the iterator variable. We'll call it I, because that's just programming tradition. So we call it I, and we'll set it to 0. And this is the equivalent of iter in our while loop. And we are going to be counting to 10 again the same way that we did in the while loop. So after the iterator, you type a comma, and then you give the for loop the number that you want to count up to, so 10. And then after that, you just give it do and end. So now, just like the while loop, in this block we write our code, so we'll say print I, and that's it. That is our for loop, so you can see it's a lot cleaner than the while loop. We don't have the separate outside variable, and we also don't have to manually increment the I variable in the for loop. And that is because, since the for loop is specifically tailored to counting, it increments this iterator variable for us. So by default, it increments it by 1. So if we run this, just like the while loop, we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we can also modify how it increments. So let's give it 2, and then it will count to 10 by 2. We could give it 3, counts by 3s, or we could even give it a negative number, and we could change this to a negative number as well, and it counts to negative 10. So that's what you can do with the for loop. And again, the for loop is what you should use when you're counting, like if you're counting to 10 or counting to some variable that is a number. If you're counting for any reason, in almost all cases, you should use the for loop. The while loop is used for pretty much anything else. It's used for, say, a game loop if you want to test if the game is still running and you want to continue running the game code until some kind of variable is set to false. You could use a while loop for that. But if you're going to count to some number, always use the for loop. So the last loop we're going to go over is the repeat until loop. And this is very similar to the while loop, so we're going to recreate that example. So iter to 0. And there are really only two real differences between the while loop and repeat until loop, and then there are the obvious syntax differences. So we say repeat, and instead of having our condition here, we just write the block. So we say print iter, and iter equals iter plus 1. And then instead of having an end at the end of the block of code, we say until, and here we have our condition. And this is one of the real differences between the repeat until loop and the while loop. With the while loop, the loop will only re-execute if the statement is true. With the repeat until loop, the loop will only re-execute if the statement is false. So to recreate the example where we count to 10, we say iter is greater than 10. Because with the while loop, we had iter is less than or equal to 10 as a logical statement, and this is the inverse of that. So if we run this, it just counts to 10 again. And there is one more difference between this loop and the while loop, and that can be shown if we make this statement false by default. So let's say until iter is less than or equal to 10, or I mean true by default. So iter is less than or equal to 10 from the start, and that means this statement will be true, so the loop will stop running. And if this was a while loop, that would mean that this code wouldn't be executed at all. But if we run this, the program still outputs 0. And that's because the statement is only checked once this code has been finished running once. So if you use a repeat until loop, you're guaranteeing that the code in this block will be run at least once. Even if the statement is true from the beginning, so that the code shouldn't re-execute, it will execute once, because this statement isn't checked for until the end of this code. So that may seem useful, and I'm sure it can be useful in some specific situations, but I am 99% done making a game in Lua, and I haven't used this once. I actually forgot about this loop until I went back over this chapter in the Lua book to refresh my knowledge for this tutorial. So I forgot about this. I didn't know it existed. So that clearly means it's not very useful. And it says even in the Lua book that the developers are considering getting rid of it to decrease the implementation size of Lua when you use it with C. So I wouldn't worry about this loop too much if it's for any reason hard to understand the minor differences between this and the while loop. Don't worry about it. You'll probably never use this, but just in case, don't forget about it like I did, because maybe it would have been useful. So that's all the loops we're going to go over in this tutorial. There is one more called the generic for loop, but that we need to know tables for, so we'll save that for a later tutorial. And now the last thing we're going to do is control statements. So Lua only has one control statement, and that is break. And what break does is allows you to terminate execution of a loop and just move on to the next block of code. So to show you, we're going to recreate the for loop. For I equals 0, 10, and then we'll print I, and then we will end. So what we're going to do now is we're going to make it so that this loop only counts up to 5, and instead of doing that the logical way and just replacing this with 5, we're going to use break. So after print, if we say if I equals 5, then break and end, and yes, you're allowed to have the entire if statement on one line, but only do that with single line if statements. So only if the block that the if statement is executing is one line long, then you can have your entire if statement on one line. Otherwise, just use multi-line. So now what we're doing with this loop is we're making it print I, we're iterating through the loop and having it print I, and then we have an if statement that's saying if I equals 5, then break. So when this if statement evaluates to true, so I is equal to 5, then this break statement is executed, and this loop is just ended. So then it would move on to the next line of code, whatever that would be, and in this case it would just end the program. So if we run this, it only counts to 5 instead of counting to 10. So that's what the break statement does. It is very useful. And most languages have a continue statement, which allows you to end the current iteration of the loop and go back to the top and reevaluate the statement. And in the case of a for loop, it will also iterate the iterator variable by whatever value you have in the third section, and or by default 1. So the continue statement allows you to go back to the top of the loop and just end the current iteration. But because of some variable scope problems, which we'll get into variable scope in a few tutorials, but because of some problems with the way Lua works, the continue statement can't happen in Lua, so you just have to get around that inconvenience. So remember that Lua only has the break statement, not continue. So that's all for this video. In the next video we'll be going over tables, so see you then.